Hello guys, today we'll be solving a chemistry quiz for week 3 AMS. Alright, so let's get started. Alright, for first question, a certain mass of helium gas is placed in a cylinder fitted with a piston at 25 Celsius. While keeping the temperature constant, the piston is moved till the volume is decreased. The conditions of the experiment are represented in the table below. Okay, so now for this one, let's look at the given first. We have the P1, which is the pressure for the first condition. Second one we need to find, as they asked in the question. If we have the first volume, second volume, temperature is kept constant. So if it's kept constant, we don't look at it. Okay, to solve this we use a certain rule. I'll show you now. P1 V1 over N1 T1 equals P2 V2 over N2 T2. Okay, now of course before we solve, we have to insert the values to its respective condition. 120 is serves as P1, so we'll put it as 120. V1 is 3, so times 3 over. Now we don't have moles, so we cancel N1. And temperature is kept constant. When something is kept constant, we don't add it. So T1 is removed, and same thing here. N2, T2 all removed. So now we're left with P1 V1 equals P2 V2. Okay, equals P2 is the one we're trying to find, and V2 is 2. Okay, so 120 times 3 is 360 equals P2 times 2. Now, since we're trying to find P2, we can consider it as X. We just divide by 2 here, divide by 2 here. So P2 is equals to 180. Okay, and yes, we have 180 here. That's it. By the way, guys, excuse my handwriting, it's very bad, I know. Anyways, for the next question, same thing. We just look at the given. We have pressure here. We have P1, P2. They want us to find the pressure again. We have volume, but all the volume is constant now, so we don't look at it. And temperature is not constant, so now we add it to the equation. Now let's solve. Again, P1 V1 over N1 T1 equals P2 V2 over N2 T2. Now we'll add P1 to 120. We don't look at the volume since it's constant, so we cross it out, and moles is not given, so we cross it out too. So we're left with P1 over T1 equals to P2 over T2. So 120 equals P2 is the one we're trying to find. Okay, now to add the temperatures. Now, before we add them, we don't add them as Celsius, we add them as Kelvin. Remember, whenever we solve these type of questions, temperature has to be in Kelvin. Now, how do we transfer from Celsius to Kelvin, you ask? 25, we just add 273. From Celsius to Kelvin, we add 273. From Kelvin to Celsius, we subtract 273. Like this, Celsius to Kelvin, we add 273. Kelvin to Celsius, we subtract 273. Okay, so now let's solve. 225 plus 273 will be 298, and T2, which is 125, will be 125 plus 273 equals 398. Now we can cross multiply. We're left with P2 298 equals to 120 times 398, which is 47,760. So divide by 298 here, divide by 298 here. We get P2 equals to 160, and we can see we have 160 here. Alright, so that's the answer. So don't worry guys, it's easy so far. We just use the same rules and always look at the given before solving. Okay, now for this question, which of the following statements are true according to the kinetic theory? Select all that apply. Okay, this is just basically logic. We know molecules, they move faster at higher temperatures and move slower at lower temperatures. Yeah, it's logic. If you melt something, the molecules will start. Let me show you. When you melt something, the molecules that are tightly packed will start moving really quickly, and it will spread out. It will keep spreading out until it achieves a new state. And if it's lower temperature, the spread out molecules will go back in until they're tightly packed. So yeah, and they move slower, of course. So yeah, that's basically it. Logic. For question 4, what is absolute zero? Okay, when they say absolute zero, they mean by Kelvin, 0 Kelvin. 0 Kelvin is known as the absolute zero, as mentioned in the question, and it's like the coldest. Okay, so when they say absolute zero, just remember 0 Kelvin, and the second option is -273, which is exactly like Kelvin but at different degree. You know, like it's the same thing. It's just this is Celsius and this is Kelvin, but they're both equal. Now, question 5. Which of the following is true about the partial pressure of a gas? Okay, to the pressure. Okay, now what they mean by partial pressure, imagine this. Let me just picture that for you. Now, imagine a sealed container, a cylinder like a container like a Pepsi can or whatever. We put 3 types of gases. Different gases, don't have to be specific, like nitrogen, carbon, oxygen, doesn't matter. Now this is gas 1, gas 2, gas 3. Okay, now that we have 3 gases, it doesn't change anything. Like, it's no matter how many gases we put, 4, 5, 6, 7, it will still be the same volume. So that's why it is not affected by the presence of other gases in the mixture. Each gas is independent, as if there was no other gas inside the container. And secondly, it is the pressure each gas in the mixture will exert as if it were alone in the container. So, like, even if it's like 1 million gases, it will be like it will be the pressure of 1 gas only. So yeah, it's easy. May seem difficult, but it's actually really easy. Make sure to memorize, guys. Okay, we're back with these type of questions. Again, we use P1. Well, before we do anything, let's of course read the question. Never skip the question, guys. Always read it. A sample of 4 decimeter cubed of nitrogen gas is placed in a lead container, piston at 100 Celsius. Conditions are below. Pressure is constant. Okay, so now pressure is constant, so we don't look at it. Okay, now we're left with volume and temperature. Okay, so we P1 V1 over N1 T1 equals P2 V2 over N2 T2. Okay. So now that pressure is constant, we cross out pressure, and mode is not given again, so we cross it out. So now we're left with V1, T1, and V2 over T2. So now V1 is 4 here, so 4 over T1. We change it to Kelvin. Remember, guys, don't put it as Celsius. So it's going to be 373 equals V2. It's the one we're trying to find. Over 200 Celsius, we make it to Kelvin, so we add 273, it will be 473. Now we cross multiply, you'll get V2 373 equals to 473 times 4, which is 1892. Divide by 373, divide by 373, you'll get V2 is equals to 5.07. Now it's more numbers in the calculator, but since I wanted to do 3 significant figures, so we just add these 3 numbers only. 1, 2, 3, three significant figures. So we put it as 5.07. So that's the answer. Okay, let's move on to the next question. Okay, for this one, there's no way to explain this since it's just a fact, you can't explain a fact. It's just something you have to memorize. So memorize this and that's it. Just memorize it as a fact, Okay, now we moved on to the past questions. Okay, now for these type of questions, always read the given before solving, okay? Because there's always an easier way. Because there's many ways to solve this, but finding the easier way is always the most efficient way of solving the exam, since we don't have much time. Okay, for part A, find number of moles of chlorine reacted. Alright, let's look at the given now. We have 14.2 grams of chlorine and its molar mass also. So now that we have mass and molar mass, we can use N equals mass over molar mass to find it. So N equals mass 14.2 over molar mass. Since it's chlorine 2, you have to make it into 71. Since 35.5 times 2 is 71. 14.2 divided by 71 is 0.2. Now they wanted to 3 significant figures, so we add 2 zeros to make it 3. So 1, 2, 3 significant figures. Of course, we don't count the 0 which is after the decimal. Alright. Now for part B, find number of moles of sodium chloride produced. Okay. Now for this one we have to use ratios. Okay. Okay. For this one we have to use ratios. They want moles of sodium chloride. Okay, which is this one. And the easiest way to solve this is to use something we already have the moles of. And we have the moles of chlorine. So we can use chlorine also. So chlorine is 1 to 2. Since it's here is 2. So 1 to 2. This is chlorine. This is NaCl. And under 2 is the one we're trying to find, which is X. And under 1 is the mole we already found, 0.2. Cross multiply X equals 0.4. And you can see it's the answer. They wanted 3 significant figures, so we add 2 zeros. So 1, 2, 3 significant figures. So the answer will be 0.400. Okay. For part C, this is simple. Since we already have, they want us to find the mass of sodium chloride. Since we already have the moles of it, we can just use this rule. We can use mass equals moles times molar mass. Okay, so now mass is the one we're trying to find. Moles is 0.4 times molar mass. What's the molar mass? It's covered, so 23 and 35.5. 23 plus 35.5 will be 58.8. Wait, what? No, sorry, 58.5. So you multiply 0.4 by 58.5, you get 23.4. Since it's already significant figures, we just put it as it is. If you guys asked how I got the molar mass, they want sodium chloride, so NaCl, which is 23 plus 35.5. That's it. So easy, don't worry. Okay, for this one, the same thing, but this time they want us to balance the equation. And let's look at the question, of course, as always. We look at the given. Okay. We have sodium metal, Na, plus excess water, which is H2O, gives explosive reaction equal to producing aqueous solution of sodium hydroxide, which is NaOH, plus H2. Now for this Na here, H here, O. Now they want us to balance. We have one Na here and one Na here, so it's going to be 1, and H here is 2, and H here is 1 and 2. So we do 1 plus 2. We don't make it 3 since they're not in the same element. And O is 1 here, and O is 1 here. So everything is balanced except hydrogen. Since here's 2 and here's 3. Now, a simple way to do this would be to just half this, and if we have this, it will become 2, like here. So we multiply the 2 by 1.1 over 2. Let me just put it. It will be times 1 over 2, the h, which will be in which one? Over here, 1 over 2 with the h2. So when we put fractions in balance, we don't like fractions, so it's so messy. 1 minute, guys. Okay. And 2 and 1. Okay, say they want Na plus H2O gives NaOH plus H2. Since here is 3 and here's 2, we just half it. We just half the 2 to make it 2. So we multiply the 2 by 1 over 2. So we put 1 over 2 here. But when we balance, we don't like fractions. So we just cancel. We can just cancel the denominator and multiply the denominator by the whole equation. So here it will be 1, and here we multiply by 2, multiply by 2, and multiply by 2. So it will be 2Na. Look, multiplying 2 here, multiplying by 2 here. It will still be balanced, just doubled. And hydrogen is balanced to be here. It's going to be 2H and 2H here. So it's going to be 4 here. And 2H2 is 4. Since 2 times 2 is 4. So here is balanced. Na is 2 times Na is 2Na. 2 times Na is 2Na. So it's balanced also. And H, we have, and same thing where you did H. O is 2 here, and O is 2 here. So it's balanced. So now the equation will be 2Na plus 2H2O equals to 2NaOH plus H2. Of course, add the state symbols, don't forget. Okay? Now, for the second one, they want the number of moles of sodium metal reacted. Since we already have the balanced equation, we can just use this. Okay, since they want the moles of sodium metal, which is this one, we can... Wait, I have to look at the other question. Yeah, we look at the given. We have 4.6 grams of sodium metal and 23 as the molar mass of Na. Okay, so 23 is the molar mass, and mass is 4.6. Now we can use N equals mass over molar mass to find the moles of sodium metal. So N equals 4.6 over 23. 4.6 over 23 is going to be 0.2. And here we can see we got 0.2, but they wanted the two significant figures, so don't forget to add this extra 0. Alright? Now for the third one, number of moles of hydrogen gas released. Okay. Now, since we already have, now that we don't have the given mass of this, so we can't use N equals mass over molar mass. So I have to use ratios. Okay, number of moles of, since we already have sodium, we can use sodium to hydrogen. Sodium is 2 to 1, and under sodium is 0.2. And what we're trying to find is the moles of hydrogen. Cross multiply, 2x equals 0.2, divide by 2, divide by 2, x equals 0.1. The two significant figures, so we just add in 0, so it will be 0.10. That's all. Okay, this is a new question. A rigid sealed vessel contains a mixture of 3 different gases kept under the same conditions of temperature and pressure. The volume occupied by each gas is equal to the total volume of the vessel. Okay, look, it's not something to explain, but I'm just gonna explain either way. Remember, no matter how little gas there is or more or whatever, its volume will always be equal to the volume of the vessel itself. Alright, that's the gas. It's only for gases, remember? It will always be equal to the volume of the sealed vessel. Alright? So that's something you should memorize. Okay, another past question. Okay, this seems simple. Alright. Oops. Wrong mode. Okay. So for this one, we have to balance again. So we'll do Fe equals, since we're already given the equation, we can just apply it على طول. Fe here, Cl here, Cl here. Fe will be 1 here and Fe will be 1 here, so they're balanced. And Cl will be 2 and Cl will be 3. It's just simple, we can just multiply by 3 here, multiply by 2. If we multiply by 2 here, we have to multiply by 2, and here we can multiply by 2 to make it equal. So it will be 2Fe, 3Cl, and 2 here. So 2Fe plus 3Cl plus equals to 2FeCl. That's it. And now for the second one. They want the number of moles, how many moles of chlorine are needed to produce 6 moles of iron chloride. Okay, we need to use ratios. They're giving us the moles of chlorine, so we can use chlorine. So 1 to iron chloride. So 1 chlorine to 1 FeCl. Oh, oops, sorry, I'm using the unbalanced one. We have to use this one. 3Cl to 2 FeCl. So we'll use 3 to 2. Since we're already given the moles of chlorine, we use 6. We put 6. Oops, sorry, no. They give us the mole of iron chloride, so we put 6 under the FeCl. And we are trying to find the mole of chlorine. Okay, so we just cross multiply. 18 equals 2x. Divide by 2. Divide by 2. X equals 9. And they wanted 2 significant figures, so we just put it to 9.0, and yeah, we have 9.0 here. Okay, for this one, another past question. We look at the given, of course, as always. Whenever, right, like I said, whenever you see these type of questions, always look at the given. They will guide you throughout the question. Okay, we have the molar masses of Al and aluminium and oxygen, and we have the mass of aluminium given. But before we apply it, we realize it's kg. We have to make it into K into G. So kg into G, we have to multiply by 1000. So 108 times 1000 will be, okay. So we multiply it by 1000, it will be 108,000, okay, over the molar mass of Al. Okay, right. If they want us to find number of moles of aluminium. Okay, we use the mass of aluminium and the molar mass, which is 27. We divide 108,000 divided by 27 will be 4,000. Now, they wanted to 4 significant figures, so we add a dot after it. Remember, if it's trailing zeros, no decimal in the number itself, we have to add a decimal after it. Or otherwise, the zeros won't count. Like, for example, 4,000 is just 1 significant figure. But if we add a dot at the end, it's 4. Alright? So, yeah. Second one. We calculate the number of moles of oxygen gas consumed by a reaction. We can use ratios for this. So, wait, I have to look at that. Okay. So we use ratios. We already have the moles of aluminium, so we just put 4 to for oxygen is 3. So 4 to 3. We're trying to find the moles of oxygen, so we put X under it, and under 4 we put 4K, which we already found in the first part. Cross multiply, we have 4x equals 12,000 divided by 4 divided by 4, x equals to 3,000. And same thing, they wanted to 4 significant figures, so we just add a dot at the end. The mass in kilograms. Okay, for this one, we can just use m equals moles times molar mass. Okay, for oxygen gas. So the number of moles of oxygen gas is 3,000 times the molar mass, which is, it's up there, but we know O2 is 32. Since 1 O is 16, we multiply by 2 is 32. So multiplied by 32, 3,000 times 32 is 96,000. Okay, but then they want it in kg. Since we already converted to G in the first part, we have to convert it back to kg. And by doing that, we just divide by 1,000. So 96,000 divided by 1,000 is 96.00, and they wanted to 4 significant figures, so we add 2 zeros. Alright, that's it. So to recap, we use mass equals moles times molar mass. The moles of oxygen times molar mass is 96,000. Since it's in G, they want it in kg, so we just divide by 1,000, you get 96.00. And that's it. Now question 13. This is easy. We just use the same thing I told you before to convert from C to, I'll just write it down, C to K. Okay, so from C to K, no space here. Okay, so from C to K, we add 273, and from K to C, we subtract 273. Just memorize this, very important, because we'll use this like in most of the questions, as you've seen already. So very important to memorize this. So just apply this rule. From Kelvin to Celsius, you subtract by 273, so 483 minus 273 is 210. And same thing for the other ones. That's it. Now question 14. What are the pressure and its unit that support a column of 760 at 0 Celsius? Okay. Remember, right? Remember, for STP, standard tip pressure and temperature, it's the conditions are 0 Celsius at 1 atmosphere. Got it? So remember, when you see pressure at 0 Celsius, it's always at 1 atmosphere. Got it? Again, this is something to memorize. Now for the final question, the pressure exerted by an ideal gas becomes 0 when the temperature becomes negative 273. Okay. When they mean by ideal gas becomes 0 is 0 Kelvin. Okay. So when the temperature, they want it in Celsius, so again we just subtract by 273 to turn it into Celsius. So 0 minus 273 is negative 273. And that's it. So don't worry guys, it's an easy exam. Inshallah you all do well, and I wish you the best of luck. Hope this helped, and good luck.